Hey, we're going to look at functions and their features. And if it sounds weird in the background, it's because my husband is cutting carrots. So, first off, let's think about independent and dependent variables. Independent variables are the x-axis variable. In basic student budget, remember that is usually the time variable. The dependent variable is the y-axis. It's the thing we're measuring. So again, basic student budget, we are measuring the money. All right, if you have to pause the video to write your notes, that's totally fine, okay? Domain is the all possible x values in the graph, table, or equation, and the range is all possible y values. There are two different ways to write the domain and the range. One is set notation. So this is it's usually written like this, with a curly bracket, and you write the minimum x value is less than x and is less than the maximum x value. You can also have less than or equal to signs here. Okay. It's written the same with the y's, but instead of the x in the middle, we say the y to the max. All right. Interval notation is like the minimum, comma, the maximum, and then we either use a parentheses or a bracket. The parentheses means less than or less than, so the value is not included, or this minimum value is not included. The bracket means included. So it's when we use the less than or equal to sign, okay? The range is written the same, minimum, comma, maximum. Again, you can use a bracket or parentheses depending on what you need. So let's practice a little bit. First off, we want to think about like what is a function. A function is when each x value has one consistent corresponding y value. So there's one output for each input, and that is it. So you can expect the same output every single time. So looking at these examples, the first one, is that a function or not? Yes, because it passes the vertical line test. I don't have any part of the graph when I make a vertical line where the graph is going to touch one of these vertical lines more than once. So it's touching one time, 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 one time. So we're good there. Now this one, vertical line test, I have a point here and a point here on the same x value. So this is not a function. There's two y values for one x value. Okay, so I'm going to look. 0. Let's see. 0 gives me a 0. 1 gives me a 1. 2 gives me a 4. 3 gives me a 9. 4 gives me a 16. Are there any repeat x's that have different y values? No. So this is a function. Okay, this time. 3 gives me a 0. 4 gives me a 7. 5 gives me a 10. 4 also gives me a 14, or it gives me a 7. I have more than one output for a singular input, so this is not a function. Let's look at the domains and the ranges next. So, from the left to the right, reading from the left to the right, just like reading. Okay. My smallest x value is -4. I'm going to write this in interval notation. My largest x value, actually I have an arrow, so that means this graph always actually goes on forever. So comma infinity. Can you ever equal infinity? No, you get a parenthesis. Can you equal -4? No, because there's an open circle. All right, the range. The lowest part of the graph is right here at 1. The highest part of the graph, oh, that arrow, it goes to infinity. We can't equal infinity. They always get a parentheses. Can you equal the 1? Yes, there's lots of included points here at the height of 1. So it gets a bracket. Oh, I made a mistake. Can you equal -4? No, so it gets a parentheses, not a bracket. Okay, the next one. My first point in the x direction would be at the vertex here. That's x equals 0. And the arms extend out forever to infinity. So that's parentheses. There's no hole at the vertex, so we are able to equal 0. The range. The arms go out to infinity, so -infinity to a height of infinity. These are both infinities, so they both get parentheses. Okay, the domain for a set of table values looks like this. You put a bracket, means the set, and we just list the x's are 0, 1, 2, 3, and 4. The y's, so this tells me the set of y is 0, 1, 4, 9, and 16. The range is for the input, the set is the input, is 3, 4, 5. The 4 is repeated, so I don't have to put it again. And the range, the output, because that's what's labeled here, is 0, 7, 10, 14, and 25. So any unique number, you need to list it. These are the possible inputs and the possible outputs. That's what the set means. Possible inputs, possible outputs. All right, we are going to find the domain and range of these guys. But first, there are some special things to look out for when we're dealing with domain and range. So anything that will give me a 0 in the denominator is going to break my function. So we're going to look for any kind, if there's a fraction and there's an x in the bottom, we got to be careful of that, okay? Anything, what kind of numbers can't you take the square root of? I cannot take the square root of negative numbers and get a real value. So what kind of numbers would give me a negative underneath the square root? We're going to look for those too. All right, so A, finding the domain. X squared plus 2. What type of graph is that? Oh, that's a quadratic. It's going to look like this, right? Do we have any restrictions on a quadratic? No. So not in the x direction. So this is going to be, the graph extends to the left from -infinity to infinity. And that's it. The next one, I'm like, okay, this is cray, but it's a fraction. And so I'm going to look in the denominator. What can't you divide by? You can't divide by 0. So we're going to use this trick. We're going to take this calculation on the bottom, x squared plus 1. I'm going to say, what x's would I plug in to give me 0? And you're like, okay, let's see. Let's solve for x. Okay, x squared equals -1. I'm going to take the square root. I'm like, square root of a negative number, that's undefined. So, therefore, I'm going to use this little triangle symbol, meaning therefore, the 3 dots. X is equal to, oops. Let's say this. Therefore, there's no value for x in x squared plus 2 that would equal 0. So the domain is all real numbers. So there was no restrictions in this because there is nothing that you can plug in for x to give you a -1 to offset the +1 to make 0. All right, the last one. Ooh, that's a square root. So I know I can't square root a negative. So I'm going to look inside at 1 minus x. Okay, so I'm going to take 1 minus x. And I know that the answers to this equation have to be, to the inside of this, have to be greater than or equal to 0. Because can you square root a positive number? Yes. Can you square root 0? Yes. But as soon as it gets lower than that, you can't do it. Okay? So, subtract 1. I get negative x is greater than or equal to, -1. Divide by -1. I get x, and 1 divided by 1 is 1. Remember, when you divide by a negative, we're actually flipping the sign. So x has to be less than or equal to 1. So that's how we deal with square roots. So if I think about this for a second, if I make this less than 1, 0. 1 minus 0 is 0. So that is going to be the square root of 1, which is 1. If I make this -1, the square root of 1 minus -1 would equal, well, that would change to a positive, so the square root of 2. So anything less than, so I'm just going to verifying that this works. This totally works when the values are less than 1. Okay. Function notation. This is also a review. We're going to replace the -4 with x. So here's my function. So -4 squared minus 3 times -4. 4 times -4 times -4 is positive 16. Negative times a negative gives me a positive 12. So f of -4 is 28. All right, next one. We're going f of x is equal to 4. So this is my y value. So I'm going to be like f of x is equal to x squared minus 3x. All right, this f of x is equal to 4. So I'm going to replace that. So it's the output. How do you solve a quadratic? We get a 0 on one side. So 0 is equal to x squared minus 3x minus 4. Then you got choices. Quadratic formula, big X. We go with big X's. -4, -3 on the bottom. So what multiplies to -4 adds to -3. I think that's -4 and 1. So 0 is equal to x minus 4 times x plus 1. Am I done? Nope. Now I have to use zero product property. So x minus 4 is equal to 0. And when x plus 1 equals 0, I get 0 in the end. So we can see that my answers are 4 and -1. Okay, the last one here, f of x plus 2. So this whole thing here is going to replace any x value. So I'm just going to write it up here. F of x is equal to, and put it in parentheses, x squared minus 3 times x. These x values are getting replaced with the x plus 2. So I get x plus 2 squared minus 3 times x plus 2. How do you multiply x plus 2 squared? I'm going to use what somebody called the Punnett square, or the area model. Get x squared, 2x, 2x, and 4. So for the first part, I get x squared plus, combine these, 4x plus 4. The second part, I'm going to distribute a -3, so -3x minus 6. And I get Now I can combine my like terms. So those are like and those are like. So x squared plus x minus 2. And I am done. All right, the last thing we're going to look at is operations with functions. So we've done this forever, but there is a kind of a different way to write this. So if you see something that looks like this, f plus g of x, what they're saying is you're going to combine two functions, f of x plus g of x. Okay. Same with these are those. Multiplied inside the parentheses, that means that the two functions are being multiplied. Divide by the functions, it means that both the functions are being divided. So here's an example. We're going to use f of x and g of x here. So f plus g of x, that is just a fancy way of saying f of x plus g of x. Okay. I've also seen it written as f plus g, the function f and the function g. All right. So we get f is x squared plus 9. And g of x is 3x plus 5. So I'm going to go ahead and add on 3x plus 5. That's my g of x. And now we just combine the like terms. So x squared plus 3x plus 9 plus 5 is 14. And that is equal to f plus g of x. This says that the input is x. So x is is my independent variable. All right, and that is your answer. Next one, f minus g. So I'm going to start with f, which is x squared plus 9. Okay, and I'm going to subtract g of x, which is 3x plus 5. Make sure you put it in parentheses. All right. Now combine your like terms. So x squared plus 9, distribute, minus 3x minus 5. So I get x squared minus 3x plus 4 is equal to f minus g of x. Okay, this is not multiply by x. It means what? That the x is the input. That's the input to the function or input to the equation. That means that your x right here is your variable in your equation. Okay, f times g. I'm going to rewrite these. F of x is equal to x squared plus 9, and g of x is equal to, I don't remember, 3x plus 5. Okay, so f times g, same thing. F of x times g of x. So we get, we put those in blue. So x squared plus 9, all of that multiplied by 3x plus 5. And I'm going to go ahead and distribute. So x squared times 3x is 3x cubed. X squared times 5 is 5x squared. 9 times 3x plus 27x. 9 times 5 plus 45. Are there any like terms to add? Nope. So this is f times g of x. Am I multiplying by x? No, leave it. Okay, f over g. So x squared plus 9 over 3x plus 5. Can I simplify that? Let's big X the top. Big X. 9 on top, 0 on the bottom. Let's see, 3 and 3. Those don't add to 0. Okay, negative 3 and negative 3. Give me 9. Those don't add to 0. So x squared plus 9 is not factorable, so that's as far as I can go. Now it says to state the domain. What x value is going to give me a 0 on the bottom? If you take the calculation on the bottom, 3x plus 5, and set it equal to 0, we can solve for x. I get 3x is equal to negative 5, and then divide by 3. So x is equal to negative 5 thirds. So when x equals negative 5 thirds, we're going to get a 0 on the bottom. So what I know about the domain is that this is the only value that I actually cannot equal because it will give me my illegal 0. Okay, this is my domain. All right, we got some options for f plus g of 4. So remember, what is the 4? That is our input, our x value. So I'm going to look at this like this. We're going to be like f of 4 plus g of 4. Or you can go back and take our equation here and plug that in. Let's just... Okay. Let's take this equation. Okay, so what I can do is f plus g of 4. So I've already added f plus g, which is this guy. So all I have to do is plug in the x value now. So 4 squared plus 3 times 4 plus 14. That gives me, let's see, 16 plus 12 plus 14. So that looks like that's 28, 42. So f plus g of 4. All right, and that's it. You can also plug in each function individually and then add them together. All right, we're going to do f over g of negative 1. So I'm going to take my f over g. F over g of x is equal to x squared plus 9 over 3x plus 5. And now what I'm saying is I want to plug in negative 1. So I'm going to do negative 1 squared plus 9 over 3 times negative 1 plus 5. And that equals 1 squared is 1 plus 9 over negative 3 plus 5. Just going to write it out. So 10 over 2 is equal to 5. And we're done. Sorry, that was a long one.